Suppose from a tensile test of a dog bone specimen, you got this force displacement curve. Initially, the force response increases sharply, somewhat linearly, but then necking starts and eventually fails due to damage. This picture is after complete damage. If we look from these sides, we see the fracture surfaces. Here, force multiplied by displacement is energy. Energy required for this test includes fracture energy. Also, this plastic energy for the plastic deformation which happens little away from these fracture surfaces. And there are other minor source of energy. So the energy required for this test can be found by integrating this force displacement curve. As this curve consists of many test points, you can basically load these points in MATLAB in two arrays, one array of displacement and another array of force. This MATLAB command TRAPS can give you the area under this curve directly. Further, if you want, you can use a scale to measure these fracture surfaces. And further, if we consider this matter to be brittle or quasi-brittle, then the mode 1 fracture energy would be area under this curve, the energy divided by the area of this crack surface. So for example, if the area under this curve is 70 Newton millimeter, so displacement in millimeter, force in Newton, and you have measured the area of these fracture surfaces are 10 millimeter square, then your fracture energy is 7 Newton per millimeter.